Let's learn how to name hydrocarbons, basically those that belong to the family alkanes, alkenes, and alkynes. Now, to give you a quick recall, alkanes were hydrocarbons which only had single bonds between their carbon atom, whereas alkenes, they were hydrocarbons which had at least one pair of carbon atoms with a double bond in between them. And alkynes had at least one pair of carbon atoms with a triple bond in between them. And we saw that there are so many in number, and that's why we need to name them. See, we cannot talk about any of the hydrocarbons without knowing the names of it, right? We need to refer to them by some name. And we could have given them some random pet names. But since there are so many in number, it will be extremely difficult to remember so many names. And that's why we need to have an intuitive way of naming them. And yes, we do. See, every hydrocarbon name has two parts to it. One, the root word, and second, the suffix. The root word tells us how many carbon atoms are present in the molecule. And the suffix, it tells us whether the hydrocarbon belongs to an alkane family or alkene or alkyne. Basically, are all the bonds single bond or are there double or triple bonds present? And with just these two information, you will be able to name many hydrocarbons. For example, if I'm thinking of a hydrocarbon which has two carbon atoms, okay, and one double bond between them. With just these two information, you will be able to guess which hydrocarbon am I thinking of. You will write two carbons and then a double bond in between them. Rest all valencies will be satisfied by hydrogen. That's why this is a hydrocarbon. So yes, this is the hydrocarbon that I was thinking of. So yes, these are the two information needed to name a hydrocarbon. Now let's look at each one of them in detail. So root words are words that denote the number of carbon atom present in the molecule. And traditionally, we have been using these root words. If there is only one carbon atom, then we use the root word meth. For 2, we use the word eth. For 3, prop. For 4, but, and so on and so forth. So for example, if I had this molecule to name, so first of all, I'll focus only on the carbon atoms. And here I see that there are 3 carbon atoms. So for 3, to denote the presence of 3 carbon atoms, I will use the root word prop. Let me write it down. Prop. Similarly, let's look at one more example. Can you pause and guess what will be the root word for this compound? If you have tried it, let's see. See, this one has only one carbon atom, okay? And for 1, we use the root word meth. Let's look at one more example. Pause and try to name the root word for this one. So here, if you see, there are only 2 carbon atoms present. So here we will use the root word eth for this. Eth. Now let's talk about the suffix. See, this is a word that gets added to the root word, and it denotes whether the molecule belongs to alkane, alkene, or alkyne family. For example, if there are only single bonds between the carbon atoms, that means the molecule is an alkane and will have the suffix "ane" added to the root word. If there is even one double bond between 2 carbon atoms, that means the molecule belongs to the alkene family and will have the suffix "ene" added to the root word. And if there is even one triple bond, that means the suffix will be "ine." For example, let's look at the first molecule. So if I just focus on the bonds between the carbon atoms, you can see that there is one double bond. 2 carbon atoms have a double bond in between them. Okay, so that means this carbon chain will belong to the alkene family, and therefore the suffix added over here with the root word will be "ene." Let me write down. "Ene." And so the name is going to be prop-ene. Now, if you look at this example, over here there is only one carbon atom, okay? For alkane and alkene, you need minimum 2 carbon atoms. So definitely this is an alkane. And for alkanes, the suffix is "ane." So the suffix "ane." So the name of this molecule will be methane. Now let's look at this example. If I just focus on the bonds between carbon atoms, you see that there is a triple bond between them, right? So that means this molecule belongs to the alkyne family and they will have the suffix "ine." So to the root word, I will add the suffix "ine." So the name of this molecule is going to be ethine. So with this, we saw how to name hydrocarbons. Basically, there are 2 parts: root word, which denotes the number of carbon atoms present, and suffix, which denotes whether it belongs to the alkane, alkene, or alkyne family. Now, one thing to note over here is that here we are only talking about single carbon chain molecules. Okay, there is no branching that is happening over here. When branching happens, the rules of root word kind of changes a little bit. We'll talk about that in future videos. And also we are talking about simple alkenes and simple alkynes, meaning there are only going to be one double bond or one triple bond. There could be multiple double bonds in an alkene, okay? And for that, the suffix rule kind of changes a little bit. We'll talk about that also in future videos. Now, so far we have seen that if we are given with the structure of a hydrocarbon, then how to write its name. Now, what if I give you the molecular formula of a hydrocarbon, like C4H8? How will you write its name? Well, if you did not know anything, you would say that, I would go with the same logic. First, I will find out the root word and then the suffix. So the root word denotes the number of carbon atoms. And that's easy to find out here. It's already given that there are 4 carbon atoms in this molecule. So for 4, we use the root word bute. So let me write that down. The root word for this molecule will be bute. Now suffix, this denotes whether the molecule belongs to the alkane family, alkene or alkyne family. Now how do we find that out? By just looking at the formula. Well, if you recall, in a previous video of alkane, alkene and alkynes, we talked about the general molecular formula. Alkanes' general molecular formula was CnH2n plus 2, which means that all the alkanes will have the number of carbon atoms and hydrogen atoms in this proportion. Meaning all alkanes, their hydrogen atoms will be twice plus 2 the carbon atoms. For alkenes, their general molecular formula was CnH2n, meaning all alkenes will have twice the number of hydrogen atoms than the carbon atoms. For alkynes, their general molecular formula was CnH2n minus 2, meaning the hydrogen atoms will be twice carbon atoms minus 2. Okay? Now using these, we will figure out whether this molecule is an alkane, alkene or an alkyne. So over here I can see that number of hydrogen atoms, this is twice the number of carbon atoms. 4 2s are 8, right? And that only happens in the case of alkenes. Alkenes have twice the number of carbon atoms. So this should belong to the alkene family. And for alkene family, the suffix used is -ene. So let me write that down. -ene. So this molecule has to be butene. Okay. Now with this, let's see if we can solve a couple of more examples. Can you pause the video and try to find out their names? Now if you have tried it, let's see. So this compound has 6 carbon atoms. So for 6, the root word used is hex. That'll be the root word. Now let's talk about the suffix, whether this belongs to the alkane, alkene or alkyne family. Well, how I like to remember is I quickly calculate whether the hydrogen number is twice that of carbon. If it is, then it will be alkene. If it is 2 more than twice, then it will be alkane. 2 more than twice. And if it is 2 less than twice, then it will be alkyne. Okay. So here I see that 6 2s are 12. Okay. But this hydrogen number is 14, 2 more than 12. And 2 more than twice is alkane. So this is an alkane molecule. And therefore the suffix is going to be -ane. So this compound will be hexane. Now let's do that for this molecule. This has 9 carbon atoms. So for 9, we use the root word non. Non. And let's see if it's alkane, alkene or alkyne. The hydrogen atoms is 9 into 2 will be 18, but it is 2 less than 18. So it will be alkyne, 2 less than twice. So for alkyne, we use the suffix -ine. So the name of this compound is going to be non-ine.